This is a video for those of you that are wanting to do the optional final to increase your grade for the semester. So to do the final, you have to do this review, and I really recommend that you do it on your own and then use this video to check your work. Or if you're really stuck, you can watch the video to get some help. But do not just write down the answers without really thinking about it and trying to understand it yourself, because this is your best way to prepare for the final. So I'm going to go through it kind of briefly or quickly because it's a long packet and I don't want to have a really long video. So you may want to jot down questions if things are going too fast for you. Pause it, try to understand, write down questions, and you can come see me before you do the final. So Unit 1, Mathematical Reasoning, number 1, Simplify, Show All Work. So we're going to do order of operations, which PEMDAS is a good way to remember that usually. So P, E, M, D are on the same level, and then A, S. So parentheses, or any grouping symbols, then exponents, then multiply and divide, then add and subtract from left to right. So I'm going to do inside these parentheses first. So I'm going to keep it negative, bracket. I'm going to do 12 minus 2 to the third, so those exponents. That's 2 times 2 times 2, which is 8. And then divided by 4. Next, I'm going to do the parentheses, so I'm going to do the 12 minus 8, which is 4, and then divided by 4. Now I'm still working within the brackets, so I keep that negative sign out there. 4 divided by 4 is 1, so I get negative 1, or the opposite of 1, which is just negative 1. That's my final answer. The next one, I can do my parentheses first. So it's going to be 18 over negative 3 plus 4. This means times. 8 divided by 2 is 4 minus 5. So now I do multiply and divide from left to right. The parentheses here around the 4 don't really mean parentheses. That just means multiply now. There's nothing to do within there. 18 divided by negative 3 is negative 6 plus, now I can do 4 times 4 is 16 minus 5. Now I just go left to right. Negative 6 plus 16 is 10 minus 5, and that final answer is 5. Number 2, given w equals negative 2, x equals 8, and z equals negative 1, evaluate. So I'm going to plug in these numbers. It's going to be 3 times negative 2 minus 4 times negative 1 all over negative w is negative 2. Don't forget the extra negative on the bottom. Okay, 3 times negative 2 is negative 6 minus 4 times negative 1 is negative 4 over negative 2 means the opposite of negative 2 is positive 2. This becomes negative 6 plus 4 over 2, which is negative 2 over 2, which equals negative 1. Final simplified answer. For part B, z is negative 1 minus 3 times w's negative 2 squared plus x is 8 divided by w is negative 2. Okay, I think I wrote that right. So I'm going to square first. So negative 1 minus 3 times negative 2 squared is positive 4. Plus, now I can do this. 8 divided by negative 2 is negative 4. Negative 1 minus, I need to do this multiplication first. So negative 1 minus 12 plus negative 4. That's going to be negative 13 plus negative 4, which is negative 17. If you think I'm wrong on anything, please come tell me in class. I'm going so fast, I'm not really having time to check my answers, so I could make mistakes. So let me know if you think I did. All right, number 3 says simplify. I can't solve. There are variables here. I don't know what they represent. So all I can do is combine like terms. Negative 3x and positive 7x means I really have 4x. And then 5 and 6 mean I really have 11. So 4x plus 11. It's as simple as it gets here. Number 4, let's see. I need to distribute the 4 times 4, so that's 16, and then that's going to be minus 28n, and then I still have that minus 5n. These are like terms, so I have 16 minus 33n. That's as simple as we get here. Number 5, distribute, so that's negative 6w plus 12 plus 10 plus 14w. And combine like terms, this means I've got 8w, and then I've got plus 22. Next one, distribute the 2, that's 18 minus 8n, that's going to be plus 2n minus 5. So I can do 18 minus 5 is 13, and then I have negative 8n plus 2n is minus 6n. I could have done in the other order, negative 6n plus 13 would still be right. All right, number 7, translating from the verbal expression to a numerical. 5 more than the quotient of a number and 7. So the quotient of a number and 7, quotient means divide. It's going to be the number divided by 7. I want 5 more than that, so I'm going to add 5 to it. Product of 4 and a number, product means multiply. I'm going to do 4 times the number, I'm going to just call it n. You could call it x, call it whatever letter you want. The sum of y and 9, that means y plus 9, means equals. The sum of y and 9 is twice, that means multiplying by 2, the difference of n and 2. So I need to put parentheses around this. That means n minus 2. Difference means subtraction. Must have the parentheses there because I want twice the whole difference, not just twice n. I want the difference of n minus 2 doubled. 10 less than 1/3 of z. So first I want to start with 1/3 of z. 1/3 times z you could do z divided by 3. I want 10 less than that, so I'm starting with that and then I'm taking away 10. All right, so 10 less than 1/3 of z is, that means equals, the same as, but still part of the equals, 8 more than w. So I start with w, add 8 to it. You could say 8 plus w, that's equivalent, but I think w plus 8 is technically more in line with the words there. All right, next page. Write each word in below the operation where it belongs. Okay, so I've got addition right here, subtraction, multiplication, and division. So each of these words belongs in one of these categories. So I'm just going to go through each one. Product is multiply. Minus is subtraction. Divided by goes in the divided by column. Oh, I can barely reach that. Difference is subtraction. Addition is kind of obvious. Plus also goes in here. More than also. Sum, wow, there's a lot of these in a row. Twice means multiplied by 2, so it goes in the multiplication category. Less than is with subtraction. Times is multiplication. Increased by is addition. Quotient, division. Group also means division, dividing into groups. Double is multiplication. Same with triple. And then decreased by goes in the subtraction. All right, I think I got them all. Solve each equation or inequality. Show all work. Check your solutions. For inequalities, graph your solutions on the number line provided. All right, so to solve this equation, I need to distribute first. So there are other ways to do it, but I'm going to show this way because I think most people would start it this way. Negative 8x plus 14, negative times negative is a positive, equals 6x minus 42. Now I want to get my x's on the same side. I'm going to add 8x on both sides, so I don't have any negatives. So then I'm going to have 14 equals 6x plus 8x is 14x minus 42. Now I'm going to add 42 on both sides. I'm running out of room. 14 plus 42, that'd be 52, 56 equals 14x. Divide by 14. Well, 7 goes into 56 8 times, so 14 would go into it 4 times. So 4 equals x. I could check my answer, but I'm pretty sure it's right. On your test, I recommend you check it by plugging the 4 in for x and making sure it's true, especially if you have a calculator. That's an easy way to do it. To save time, I'm going to skip that step, although I recommend you do it. Number 2, x divided by 4 minus 8 equals 5. So first, I'm going to add 8 on both sides. So then I have x divided by 4 equals 13. The opposite of dividing by 4 is multiplying by 4. So if I multiply by 4, if I have now I have 4x divided by 4, that's just 1x. So the 4 on top and the 4 on bottom reduces to 1x equals 13 times 4. Let's see, that's 26 times 2, which would be 52. I can check that answer. 52 divided by 4 is 13. 13 minus 8 is 5. All right, number 3. I'm going to switch colors so I don't get confused. I'm going to have to erase so I can read better. Okay, 3x minus 4 times x plus 6 equals negative 23. I have to distribute this. So it's got to be 3x minus 4x minus 24 equals negative 23. I've got these x's on the same side. That means I want to combine like terms. If I have 3x and I take away 4x, I really have a negative 1x. Minus 24 equals negative 23. So now I want to add 24. And I get negative x equals, that's a positive 1, divide by negative 1, and I get x equals negative 1. Number 4 over here. I'm going to erase that. I need to distribute. So negative 5 times y is negative 5y minus 15 minus 6 equals y plus 3. I can combine like terms on this side. Negative 5y minus 21 equals y plus 3. I'm going to get my y's together, so I'm going to add 5y. And then I'm left with negative 21 equals 6y plus 3. Now I subtract 3. I get negative 24 equals 6y. Divide by 6. I get negative 4 equals y. I know I'm going really fast. I'm sorry again if that's too fast for you, but remember, pause, rewind, whatever you need. I just don't want to have a video that's an hour long. Number 5. Now we're doing inequalities. We treat them like solving equations, except we have to remember if we multiply or divide by a negative number, we have to flip the inequality, and then when we're done, we graph our solution on a number line. So let's do 3x plus 7 is greater than or equal to negative 8. I'm going to start by subtracting 7. I get 3x is greater than or equal to negative 15, and I divide by 3. I get x is greater than or equal to negative 5. That's my solution. To show that, I put a negative 5 on my number line. I want a closed circle because it's or equal to makes it a closed circle. And I want all the numbers bigger than negative 5, which is going to be to the right. So I shade to the right. Number 6. I'm going to erase this. I have more room. 4 minus 2x is greater than negative 4. I want to get x by itself. I'm going to start by getting rid of this 4 over here. It's positive 4, so I take away 4. So now I have negative 2x is greater than negative 8. Now I need to divide by negative 2. And this is where I have to remember I divided by a negative, so I need to flip my symbol. So it's going to be x is less than positive 4. Okay, it's not or equal to. So I put a 4 on my number line. I want an open circle. I do not want to include 4 as part of my solution because 4 is not less than 4. I want to show all the other numbers that really are less than 4, which is everything to the left of 4. Even like 3.9999999. That's what this circle means. It means everything right up to 4, but not including 4, but on the left of it. Number 7 and 8 are what we call compound inequalities. It's 2 inequalities in one, basically. So negative 1 is greater than or equal to negative 6 minus, or negative 6x minus 13 is greater than negative 7. So what we want to do is break it up into 2 parts. So here's the first part. So I'm going to rewrite that over here. I'm going to use a different color now. Let's do negative 1 is greater than or equal to negative 6x minus 13. And then we write the second part, separated by an and. When it's in between 2 inequalities, they're both true. So it's this, negative 1 is greater than or equal to negative 6 minus 13, and, where can I write this? I guess maybe right here. Negative 6x minus 13 is greater than negative 7. Okay, I'll do this in green. So here I'm going to solve just like normal, the top one. Add 13. Add 13. I get 12 is greater than or equal to negative 6x. Divide by negative 6. Little red flag should go off. We divided by a negative. We need to flip our symbol. So this is going to be negative 2 is less than or equal to positive x. That seems backwards to me. I like it when the x comes first, so I'm going to rewrite it as x is greater than or equal to negative 2. I just turned it around, which means I have to turn around my symbol as well. That's the first part of my solution. Now for the second half, I'm going to add 13 on both sides. I get negative 6x is greater than 6. Divide by negative 6, which means I'm going to flip my symbol. X is less than negative 1. And the x is on the left already. I don't need to turn that one around. So my answer is x is less than negative 1 and x is greater than or equal to negative 2. So I need to put those numbers on my number line. So let's say here's negative 2. This would be negative 1, 0, 1. Oh, all I want is negative 1 actually. So negative 2, negative 1. You know what? I'm going to space these out. I'm sorry. Let's say this is negative 2. I'm going to count by 0.5s. This would be negative 1.5. Here's negative 1. Right here and right here. Okay, so I need an open circle at negative 1, and I need a closed circle at negative 2. And I want basically all the numbers in between them. I want less than negative 1, which is to the left of negative 1, and greater than negative 2, which is to the right. So it's every number in between negative 2 and negative 1, but not including negative 1. But yes, including negative 2. Okay, I know this is a lot. It's from a while ago. Hopefully it's coming back to you. Last one of the inequalities, 2x plus 1 is less than 1, or x plus 5 is greater than 8. Those are already split up for us into two parts, which is good. So I'm going to just rewrite them to have more room. I can't reach over there. Okay, let's just solve this one. Minus 1 on both sides. We get 2x is less than 1 minus 1 is 0. Divide by 2. X is less than 0. Or minus 5 on both sides. I get x is greater than 3. So x could be smaller than 0 or bigger than 3. So let's say here's 0, 1, 2, here's 3. I'm going to do open circles at both. I'm not including these because they're not or equal to. I want bigger than 0. I'm sorry, smaller than 0, so to the left of 0, and or greater than 3, so to the right of 3. So our solutions are only the numbers that are shown on this number line. And so nothing between 0 and 3 would satisfy these inequalities, but everything to the left of 0 or to the right of 3. Okay, what do we have now? A little more inequalities. Write the inequality for the given number line graph. Okay, this is a compound inequality because it's got two endpoints, not just one endpoint. So the part that's shaded we consider to be x. So according to this, x is greater than negative 1, because it's to the right of negative 1, and x is also less than 2. So that's one way to write our answer. We could also write it as the sandwich, if you remember that. We could say negative 1 is less than x is less than 2. Either of these are good. The ones that are like in between two numbers are always an and, because you can be both of these at the same time. Any number in here is greater than negative 1 and less than 2. The ones where the arrows are pointing out, this is an or. You can only be on this part of it or on this part of it. You can't be both at the same time if you're a number. Okay, so remember the shaded part is our x. So we could say x is less than 7, because it's to the left of 7 and it's open circle, or x is greater than or equal to 11. I'm going to put the or in between that. There. Okay, number 1. Okay, now we're going to unit 3, understanding functions. Decide if each of the following is a function and justify. If you say no, be specific about where it fails. So to be a function, every input gets exactly one output. Or in other words, every x gets exactly one y. So we're looking at the table. Basically, we were looking to see if x repeats. So I've got negative 5, negative 2, 0, negative 5. Okay, so that's repeating with a different output. First it's with negative 7, then it's with positive 7. That makes it not a function. So we could say input of negative 5 has two outputs of negative 7 and 7. Those are not the same numbers. So they're different outputs, so not a function. This one, we use the vertical line test when we have a graph. So we imagine a vertical line going across this graph, and we see if it crosses anywhere more than once. And it does not cross the line anywhere more than once, so this is a function. So we could just say each x gets exactly one y. Or we could say it passes the vertical line test. The side length of a square as the input compared with its area output. So to think about that, let's make a table. X and Y. This will be the side length and this will be the area. Let's say side length is 0, the area would be 0. Side length is 1, area would be 1. Side length is 2, area would be 4. Side length is 3, the area would be 9. So if I was to repeat an x value, let's consider 1 again. Is it possible to have a different y value than what I had up above? It's really not. It's the side length, if it has a side length of 1, its area is always going to be 1. So there's no way for x to repeat with a different y, which means, yes, it's a function. So each x gets exactly 1y. Sorry, my handwriting is bad. But basically for these situation ones, you want to imagine, can the x repeat? And if it does, is it possible for it to repeat with a different y? If yes, it's not a function. If no, it is a function. For each situation, identify the independent and dependent variables, and then if it is a discrete or continuous situation. So part A, Jimmy is walking to school at a rate of 5 meters per second. When it tells us the rate, if we look at the units on there, that tells us what our variables are measuring. So 5 meters per second, that's like a slope. 5 meters for every 1 second. Slope is change in y over change in x. X is the independent, y is the dependent. So our dependent is measuring meters, our independent is measuring seconds. So our independent variable is time, which is in seconds. Our dependent variable is telling us his distance walked, and that's telling us in meters. So if we were going to make a graph of this, we would have time on the bottom, distance on the side. Is it discrete or continuous? This is a situation where he can't go from one spot to another without going through every spot in between. And he can't go from one time to another without going through every time in between. So we call this continuous. It does not mean it goes on forever. It means it would be a line if we graphed it, and there's a point every single little spot on that line. Because distance and time can both be broken down. You can have half a second, you can have half of a second, you can have half of a half, etc. Part B, Timmy sells tiny toys. He makes $5 for every toy sold. So in that case, that's a rate, $5 for every toy. So remember, it goes y over x, change in y over change in x for the slope. So that means my independent is the x, my dependent is the y. So my independent is toys, so it's going to be number of toys sold. Sorry, this is not very neat. I'm wearing this like microphone thing that's attached to my computer and I can't walk very far away from it, so that's why I have to reach here. The dependent variable is going to be money made. We don't include the numbers in this. The number is part of the slope, not part of the variable. Discrete or continuous, so think about it. He can sell one toy. Let's see if we had a graph with numbers sold and money made. He could sell 0 and have 0. If he sells 1, he'd have $5. If he sells 2, he would have $10, etc. There are no points in between these points. He jumps from 0 to 1, and from 1 to 2, and from 2 to 3, or from 0 to $5, 5 to $10. We do not go through every point in between, which means this is a discrete situation. You can't sell half of a toy or 0.3572 of a toy, only whole numbers, which makes it discrete. Domain and range. So if you forgot, domain is all the x values. It's either a set of them or an interval of them. Meaning, if it's a set, that's where we list every single x value. If it's an interval, we can't list them all. We can only say the lowest to the highest, which really depends on if it's discrete or continuous. The range is all y values. Same thing, either the set of them or the interval of them. So for this table, tables we assume are discrete, which means we're going to give the set, which means we do the curly brackets and we list least to greatest. So all the x values are -3, -1, 0, 5. It's nice because it's already in order for us. It won't always be in order, and then you need to put it in order, least to greatest. The range is also going to be the set, so curly braces, of all the y values. So 4, 8, 10, 20. Again, that one's nice because it's already in order. For the next graph, we cannot list all the x values that show up on that graph because there's actually an infinite number of x values. It's everywhere but from this point, which is at -8, to this point, which is at +8. Okay, sorry, somebody came in, so I had to pause. So I think I was saying all the x values on this graph are in between -8 and +8 because there is a point all along here where all these x values are represented between those two numbers. So we can't list them all. It would take forever because all the decimals, all the fractions in between those two numbers are included. So what we do now, we give the interval that the x values are in. So our lowest number is -8. Our highest number is +8, so we write (8). And then we either do brackets or parentheses around these. And because we are including -8, we do a bracket like that. And we want to include +8, so we do a bracket. If it had been an open circle, we would do a parenthesis. It's kind of, yeah, it's like the open circle, closed circle, colored in or not colored in thing with inequalities. Okay, now we want to think about the range, which is the y values. And so we're looking basically at our lowest to highest point. So this right here is our lowest point, and it has a y value of -2. When we go up, our highest point is right here. It has a y value of 10. Everything in between -2 and 10 has a point on the graph as its y value. So we say our lowest first, we say -2 all the way up to 10. This means the interval, everything between -2 and 10. And we are including those points, or these values, so we do the square brackets. The only time we do parentheses is if there's an open circle or if it's an infinity, because you can't technically include infinity in your graph. Okay, the next one, it should have had arrows drawn on here. I'm sorry that it didn't print that way, but we want to imagine that there are arrows. And I don't even think I can reach that far. That's as far as I can reach. Pretend that's going down forever. So our domain, all the x values, if this goes side to side forever and down forever, it's gonna go, there's no end point, there's no leftmost point for x values, so it's going towards, we call it -infinity. And same, it's going to the right forever and down, but we're just thinking left to right for domain. It's going towards +infinity. And we always do parentheses around infinities because you can't technically include them. Now for range, we're thinking low to high. It's going down forever, so it's going down towards -infinity with a parenthesis. It's going up. It does not go up forever. It does have a highest point, which is right here, which is at where y is 0. So we do -infinity, 0 with a square bracket because we do include 0. It is part of our graph. All right, number 4, now we're getting into some function notation. Let f of x equal 4x minus 6. Find the following. F of -1. We plug that in for x. So that would be 4 times -1 minus 6, which is -4 minus 6, which is -10. F of 10 would be 4 times 10 minus 6, which is 40 minus 6, which is 34. Part C, find x when f of x equals -2. Now it's telling us, instead of the input, the x value, it's telling us the output, which is like the y value or the f of x value. We put -2 in where f of x is and solve. -2 equals 4x minus 6. So add 6, get 4 equals 4x, which means x equals 1. 4 equals 4 times 1. Find x when f of x is -22. So -22 equals 4x minus 6, add 6, what is that? negative 16 equals 4x. Divide by 4, I get negative 4 equals x. Okay, number 5. We'll see how good I can reach over here. Let g of x equals 3 times 4 minus x. Find the following. Find g of 4. Put 4 in for x. That's going to equal 3 times 4 minus 4, which is 3 times 0, which is 0. G of negative 5 is going to equal 3 times 4 minus negative 5, which is 3 times 4 plus 5, which is 3 times 9, which is 27. Find x when g of x equals negative 6. All right. Negative 6 equals 3 times 4 minus x. To solve this, I want to divide by 3. Oh, that might be confusing. I could also start by distributing the 3. Maybe I should do that to not be so confusing. Okay, that equals negative 6. Sorry, I'm running out of room. I'm just going to go right here for now. Negative 6 equals 3 times 4 is 12 minus 3x. So I just distributed. Okay, now I'm going to minus 12. Minus 12, that's negative 18 equals negative 3x. Divide by negative 3. I get positive 6 equals x. Part D, find x when g of x equals 6. So I'm going to say 6 equals 3 times 4 minus x. Distribute the 3, I get 6 equals 12 minus 3x minus 12. I get negative 6 equals negative 3x. Divide by negative 3, I get 2 equals x for part D. All right, for number 6, let this graph represent the function h of x. Find h of 3. 3 is the x value. And I want to find the output when the input is 3. So I go to 3 on the x, 1, 2, 3, right here. I go to my graph, it's right here. The output is the y value, it's right here. It's negative 2. Find x when h of x equals 5. That's telling me the output is 5, or the y is 5. So I go to where y is 5, which is right here. Oh, I've got a point right here. I also have a point right here. I also have a point right here. There are 3 spots on my graph where y equals 5, and I want to give you the x values of those because it says find x. So here's one. X equals negative 8. Right here in the middle, x equals 0. And out here, x equals positive 8. So there are 3 answers to when the y value is 5, or the h of x value is 5. All right, last unit. Fill in the blanks with the 3 forms. Okay, the first one we did was point slope form. Then we did slope intercept. And last we did standard form. And I want to give an example of each of those. So using numbers, not the general form. Point slope goes y minus y1, which I'm just going to call it 5, equals slope, I'll say is 2, times x minus x1, which could also end up being x plus 3, let's say. Okay, slope intercept form is y equals mx plus b, so I'm going to say y equals 2x minus 10. You could use other numbers. Standard form, I'm going to say 3x plus 4y equals 17. ax plus by equals c. Graph the equation 8x minus 6y equals 24 on the grid provided. So that is in standard form. So I could either convert to slope-intercept form by getting y by itself, or because 8 and negative 6 go into 24, I'm going to find the x and the y intercept, which means when x is 0, I can solve for y. So I'm going to plug in 0 for x. 8 times 0, this part just goes away. I get negative 6y equals 24. I divide by negative 6 on both sides. I get y equals negative 4. That's the point 0, negative 4. Now I'm going to plug in 0 for y, which means now negative 6 times 0, 0. That part kind of goes away. I get 8x equals 24. 8 times 3 is 24. 3, 0. So these are 2 points that I need to put on my graph. 0, negative 4, and then 3, 0. And then I graph that. And that is a really gross line. I apologize. That's number 2. That's my label. Number 3, graph the line y equals 2/5 x minus 6. I'll do that in blue. So I start at negative 6 for my y-intercept, and my slope is 2/5, so I go up 2 over 5. 1, 2, 3, 4, 5. And I make a line. I should really make more points, and I should be using a straight edge, but I'm doing my best here. Okay, number 4, graph the line y minus 3 equals negative 2 times x plus 1. That is point slope form. I need to identify the point in here. Remember, it goes y minus y1 equals m times x minus x1. And my point is x1 comma y1, which in this case, my x1, it says plus 1 here. That means there's really a negative 1. It's x minus negative 1. I want to give the number that's being subtracted from the x. And then my y1 is a positive 3. So that's my point, negative 1, 3, and my slope is negative 2. I'm going to do this in green. So I graph the point negative 1, 3, 1, 2, 3, and I'm going to go down 2 to the right 1. Do that a few times to get a good line. Should look like that. That was number 4. That makes me feel sad how gross those lines look. Straight edges, please. Okay, write an equation of the line through the points 2253 and 3077. Okay, when I'm given points, I first need to find the slope, which is change in y over change in x, which is y2 minus y1 over x2 minus x1, which is, in this case, 77 minus 53 over 30 minus 22. Okay, that is, shoot, what, 24, 53, 63, 73, plus 4 more. So it's 24 over 8, which reduces to 3. My slope is 3. Now, I think the easiest way to do this is to do a point slope equation. So just pick one of your points. I'm going to do the first one. I'm going to do y minus 53 equals 3 times x minus 22. Could have done the other point. It would be y minus 77 equals 3 times x minus 30. All right, next one. Identify which equations are equivalent to y equals 1/2 x minus 4. Show all work you do to converge. Okay, basically we're going to be getting y by itself in each of these equations. So negative 2x plus 4y equals negative 16. All right, I'm going to add 2x, and then I get 4y equals negative 16 plus 2x. I need to divide everything by 4. So I get y equals, what is that, negative 16 divided by 4, so negative 4 plus 2 over 4x, which reduces to 1 over 2x. Okay, is that equivalent? Negative 4, positive 1/2 x. So yes, that is equivalent to this equation up here. Okay, for the next one, y plus 3 equals 2 times x minus 2. I need to get y by itself. First, I need to distribute the 2. So y plus 3 equals 2x minus 4. And I need to subtract 3 on both sides. I get y equals 2x minus 7. That is not equivalent. Next one, x plus 2y equals 8. I need to subtract x on both sides, so I get 2y equals 8 minus x, and then I divide everything by 2. Notice when we multiply or divide, we do it to every single thing. When we add or subtract, it can only apply to the thing that it is like terms with. So in this case, I get y equals 4 minus 1/2 x. There's an invisible 1 up here. Okay, that is not the same. It looks more similar, but we have a positive 4, not a negative 4. We have a negative 1/2, not a positive 1/2, so it's not equivalent. One more, y minus 3 equals 1/2 times x plus 2. So we start by distributing the slope. Y minus 3 equals 1/2 x. Half of 2 is 1, so plus 1. Then we add 3. We get y equals 1/2 x plus 4. It's close, but we need a minus 4 to be the same, so not equivalent. Alex needs to lose weight for wrestling, blah, blah, blah. Find the rate his weight is decreasing. Okay, we have a table, which is basically like having 2 points filled in of the table. We're finding the change in y, the change in x. So x, y. The y is changing from 196 to 182. That is going down 14. And from 2 to 4, it is going up 2. So that means his weight went down 14 pounds when the time went up by 2 weeks, which means his rate, if we reduce that, is -7. So -7 pounds every 1 week. That's all you have to do. You do not need to fill in the table, although you could. The following table shows data collected about pennies. Is it linear? Very few people got this question correct on the test because they did not do enough work. To be linear, we need to show that there's a constant rate of change. So we need to check it for every step of the table. From 223 to 383, that's going up 160, right? I believe. From 383 to 623, it's going up 240. Mental math here, tell me if I'm wrong. 623 to 783, that's going up 100 plus 60 more, so 160. Okay, those are all the change in y's. Now we need to find all the change in x's. 90 to 150 is up 60, 150 to 240 is up 90, and then up 60 again. Now, slope or rate of change is change in y over change in x. We need to show that for every step of the table. So it first goes 160 over 60, then it goes 240 over 90, and then it goes 160 over 60 again. Well, we know the first and the last part are the same, but are these two equal? Does 160 over 60 equal 240 over 90? We can know by either reducing it as a fraction or just using our calculator to tell us what the decimal is. 160 divided by 60 is 2.6 repeating. 240 divided by 90 is also 2.6 repeating. And I know that this is going to be 2.6 repeating as well because it's the same as the first one. It's the same rate of change every step of the table. So yes, it is linear. And this is really what you need to show, the rate of change. It's the same. Or if it ended up not being 2.6, we would say no, it is not linear. What? I thought there was a few more questions. Was that it? Are we done? Hey, I think we're done. Okay, the end. Come see me if you need help. And good luck on the final. I hope that it raises your grade. Bye.